Okay, everyone, welcome to today's webinar. My name is Mark Barfoot. I'm the Director of Business Development for Symmetrics, and today's webinar is about a new technology. We are a new reseller for PostProcess Technologies, and I'm really excited to share this technology with you guys as it can really save you a lot of time in your processing of parts. I'm sure lots of you spend a lot of time manually processing parts. This gives us some options to automate some of that process. And so for today's webinar, I have Andy Kottage, and he is going to walk through the company and a little bit about the different machines that they have. So I hope you get a lot from it. We will be taking some questions at the end of the session. Andy, over to you.
All right, thank you, Mark, and thank you to everybody that's joining us today. I am definitely excited as well to be sharing more about post-process with you here today and dive into where we add value to the additive manufacturing workflow and really a little bit about the background of our company and how we're solving problems in the post-printing stage of things. So I wanted to first introduce myself. My name is Andy Kottage. I am the lead technical trainer here at PostProcess. As you might be able to see in the top right corner there, PPTU. We've made training a priority here at PostProcess. We've created a university-style learning platform where I like to say that I'm the co-founder here of PPT University. It's something we take a lot of pride in and put a lot of energy into making sure that we're educating not just our employees here internally as we're pioneering this post-printing niche, but of course to the additive manufacturing community as well and people that could benefit from our solutions. A little bit about me, I did graduate with a mechanical engineering degree from the University at Buffalo. That's where PostProcess is headquarters here in Buffalo, New York. So Western New York, very close to our friends up there in Canada. I'm a six-figure green belt. That has a lot to do with my background, very process focused, a lot of team development. Spent a lot of time on the design side. So I spent a lot of time in the world of prototyping and doing a lot of that work up from a 3D printing space. So I'm really excited to be in a position where I'm on the other side now talking about the post printing, be able to see that entire workflow. So the first thing I wanted to get into was a little bit about who we are here at PostProcess and our mission. So we describe our mission as unleashing the transformative power of additive manufacturing with the 0 to 1 innovation. And what that really means to us is identifying a problem really before people even understood it was one. We'll dive into where a lot of the energy has been spent in the 3D printing space. And essentially, we've identified an area that was lacking. And we really had to start creating that niche sort of from the ground up and really pioneer that area. So we created comprehensive technology solutions. And you'll hear us talk a lot about hardware, software, and chemistry, all being under one roof here at PostProcess, really driving the effort to produce customer-ready 3D printed parts at scale. And those are really the two key words. You know, as you guys are all aware, when these parts come off the printers, they're not ready to just hand to a customer. And to be able to process those in a manner that allows you to truly scale and truly leverage the benefits of additive manufacturing, there needed to be a new solution to that problem. And that's what PostProcess is focused on. So I hinted at a minute ago where we see a lot of the energy in the additive manufacturing workflow being spent. That's of course on the design and build side of things. So a lot of time is spent on the design side. We hear of all different CAD packages and even some automation happening in those areas. On the build side, now that's your guys' bread and butter. Everyone knows how many different print technologies are out there, how many different printers within those print technologies are out there in different organizations. You know, there's probably, you know, almost a couple hundred different options to go with. It can be completely overwhelming because that's where a lot of the time has been spent. So unfortunately, on the post-print side of things, it's really become an afterthought. A lot of people end up purchasing their printer and find out maybe after the fact that there are some extra challenges they didn't anticipate. Maybe they're printing unique geometries, or just, you know, as they scale their operation, they realize, hey, maybe we need something else to make sure that this workflow is actually balanced. Because if ultimately you're leveraging your 3D printer and say you're printing 100 parts a day, well, if you can only remove support material on 10 parts a day, then you're really only producing 10 parts a day. So that's really the opportunity that we saw. Our founder, Daniel, has entered the additive world a decade ago, knew that there was a lot of opportunity to start really digitizing and bringing some of today's technology into this post-printing stage. So that's really where we've been spending our energy. And of course, we want to dive a little bit deeper into what this problem causes when we're not able to truly optimize our post-print solution. So what we see, and we get a lot of feedback from our customers, is that as they're scaling, as they want to really take advantage of the speed and the agility of 3D printing across all different platforms, and they want to start increasing volumes, really get these repeatable results that can truly be customer ready, they realize they have a shortcoming in their workflow. Because a lot of the current methods today really revolve around, number one, manual labor. So whether you're picking up a pick, you can see here in the picture, maybe it's a grinding wheel, maybe it's just tools almost lying around to try to get this material off, to try to get these parts really how they were intended when you design them. So you end up also reaching for maybe traditional manufacturing approaches. So your facility might already have a bead blast equipment or an old school tumbling machine. So you try to throw some parts in there and you realize maybe your parts are breaking, maybe it's very cumbersome, you don't really have the right people there that are trained properly. It's difficult to get people that are trained properly to operate this equipment. So a lot of challenges as you continue to grow, they really start to show themselves. And they don't solve the problem because number one, manual labor, of course, is always time consuming. And there's really almost this artistry element to it where someone really has to almost be a craftsman to be consistent, whether it's hand sanding or using different tools to get creative to start cleaning these unique geometries. So that's very time consuming. And then it's really difficult to get consistent results. And that's one of the biggest things we hear from our customers is getting consistency time and time again. You know, people get tired towards the end of the day, right? People, new people have to come in as you continue to grow your volume, and they might not be good as the first guy, or they have to take a while to ramp up. So you start seeing these imbalances. And then with some of this traditional equipment, as I mentioned, you get these higher breakage rates. It's more susceptible when you're getting these fragile parts. You know, these bead blasters and traditional equipment, they weren't designed for thin wall polyjet parts, right? So you start running into issues there where you're getting breakages. And then when you sum that up, it just really becomes expensive. And what we hear from a lot of customers is that they spent so much time on the print side of things is that they might not even be truly aware of how much money they're spending on the post-print side. So that's a big part of our education as well, is sort of digging into those numbers and saying there might be a bigger opportunity here than you even realize once you start diving in, because it's such an afterthought at this point. So that's the problem that we see. So of course, with that problem, we want to talk about our solution. So at a high level, these are our beliefs here at PostProcess. It's really about automating the finishing of 3D parts through a comprehensive system of hardware, software, and chemistry. And then our three key benefits. The first being consistency, which is actually the number one benefit, which kind of surprised us, but based on customer feedback, that's where the industry is going. They want parts that are going to be repeatable time and time again, whether operator A steps in, operator B or C. They want to be able to get consistent results. They want to really create a channel for unlimited throughput. And of course, they want to make an investment that's going to make them their money back. So we understand how important that is. So hardware and software chemistry all in one place is truly unique, and really our backbone being the software. So really what the software does is it ensures that the hardware and chemistry are working together in unison and really optimizing the chemical and mechanical energy. So you see a couple examples over there: motion, ultrasonics, fluid flow, heat. We get into things like pressure and friction and all these sorts of what we call rates of removal. So the software side of things really allows us to take advantage of those different energies and really optimize it. And not only that, continue to grow. So we're not a static solution. We continue to evolve because we have software as our platform. And then again, just to highlight on these key customer benefits: repeatability, again, even with complex parts. And that of course is the real challenge. You know, these nooks and crannies, interior channels, and all these different challenges that, you know, time and time again with human, just manual labor, you know, people are human and they're going to miss things, and that can become really challenging to get that consistency. And then actually removing that bottleneck, as I mentioned, if you're printing those 100 parts a day, but you're really bottlenecked to only post-process 5, then of course you're gonna run into issues, right? And then being able to produce and post-print in batches really significantly reducing labor costs. And really what we like to talk about is repurposing those labor costs. So someone might be doing this hands-on work that you can automate and use that skill set in a different way throughout the facility or manufacturing workflow that really takes advantage of some of that repetitive hands-on work and really get that ROI. So minimizing those breakages, reducing labor costs, really getting a fast payback compared to industry standards. So to sum it all up, yesterday's standards, very restrictive. It can be very expensive. Like I said, especially people start diving into it and crunching some of these numbers that tend to slip under the radar sometimes. Very time consuming. It's very hard to create a predictable workflow and make promises to customers when you create this bottleneck. And of course, we're talking about opening up that bottleneck with automated, intelligent, and comprehensive solutions. So we get into both support removal and surface finishing. It was highlighted there in the previous slide. I glossed over a little bit, but what we're going to be diving into is both our software or our support removal and surface finishing solutions to show how we could add value to you and your customers. So we'll start with the support removal solutions. And we really have two different levels, I'll call them, of support removal solutions. And first, I'll introduce just the design series. So these are very desktop compatible, very small units, might be great for the education department, very small parts, maybe very low volume. These particular units have ultrasonics and they also have heat. What they don't have is pump flow. And I mentioned software. These units have a very simple PLC software, and I'll get into our platform in a moment, which really takes it to the next level. But there is some software controls here, but these are really our small support removal solutions, and it's for basically a niche low value market. But of course, we're talking about providing people the opportunity to scale. So I want to spend more time on the production series units. And this is where we start really getting into our software, which we call automated. And I'll do a segment on that in a moment where we'll really dive into the value of automated, our platform system. But these production series units are really for high volume, low labor. So what we're talking about here is actual batch processing and really leveraging that power of software. So we get into two main technologies here. As you can see along the bottom, you have a couple different icons. So this first set here with the Centi and the Demi, this is called Submerse vortex cavitation, and we'll dive into that. And then we have the Desi and the base, which is actually a spray technology, which is completely unique to the industry, and that's our VVD, or volumetric velocity dispersion technology. So these are powerful systems to adapt to varying levels of throughputs and geometries to be able to address soluble support removal. So I want to get a little deeper into Submerse vortex cavitation. So that's going to be our Centi and our Demi. So what these units really, what we're talking about here is really creating a rotating motion while they're immersed in fluid for really disposing of the support material to provide even exposure to induce mechanical agitation. So I mentioned mechanical rate of removal at the top and chemical rate of removal. And what we're doing here is trying to move those together. So you want to submerge a part in our proprietary PPT detergent. And I'm sure you've all heard of different maybe SCA tanks or waterworks systems. You say, okay, I've submerged something before. The real difference here is, one of the real differences is the vortex action that we're able to create. So really the idea here is you might be able to submerge a part, but if it sinks all the way to the bottom or floats all the way to the top, you're not giving it even exposure to maybe temperature, ultrasonics, or really just the agitation of the fluid flow. So really we want to create this idea that we want parts that want to float. We want to get them to sink a little bit, and the parts that want to sink, we want them to float. So you really want to create this suspended action, this vortex action, to make sure you get this tumbling while it's submerged to get even exposure to the ultrasonics as well as the other mechanical energies that I mentioned. So that's the big difference. In cavitation, really just is the ultrasonic side of it. So those are essentially sound frequencies, those vapor bubbles that are considered a mechanical means of agitating the support material and really sort of working as scrubbing bubbles to be able to remove that support material. So we like to show a schematic of this. And basically what you're looking at is the vortex action here with the ultrasonics on the right-hand side. So don't want to dive too deep into this, but the technology here is really being able to suspend this part so it can get even mechanical agitation to really expedite that support removal process. And another huge advantage here is the filtration system that we have to really extend detergent life to minimize maintenance. The next technology I'll touch on is the volumetric velocity dispersion. So that's the VVD. Those are our spray technologies. So the big difference here is that we're using fluid flow. So these parts are not submerged. They're sitting on a part tray being exposed to high volume. So not high pressure. So you have pressures of only around 25 to 30 PSI, but they're getting doused in the chemical, but they're not having to submerge. So we're getting great cycle time improvements leveraging this means of mechanical agitation, this fluid flow versus just submerging. So this is another great opportunity for soluble support removal, both in the FDM, polyjet, and even the SLA resin removal side of things. So essentially all you're doing is put a part on this part tray. You have a spray rack on the top and on the bottom. The one on the top can move back and forth to create a sweeping motion. So it's really a very primitive sort of explanation of this. You can almost think of this as like popping it in the dishwasher, right? That, of course it's much more complex than that, but putting these parts on the tray, leveraging the power of the fluid flow and the chemistry really has some unique advantage to expedite that cycle time. So very minimal maintenance, simple filtration here, very much one touch button, process your parts. So a very, very powerful, unique technology in the industry today. So those are our two main support removal technologies. And I want to make sure we have time to dive into the software and the chemistry. So I'm going to get right to the surface finishing and hopefully at the end save time for questions as well. So surface finishing. We have design series and production series again here. On the design series side of things, these are designed really for just very simple one-touch pre-programmed frequency and cycle time. So really be able to give the customer just a one-stop shop, very versatile machines that are able to really minimize any sort of complexities. If someone just wants a simple operation, not really get too involved in the software side of things and just have literally a one-button touch to process a wide variety of parts, very low decibel, powerful systems. We have two designs here. We have the Radar, which is a rectangular surface finishing solution, and then we have the Levo, which is a circular, which is higher frequency. So these are one-stop shops, plug and play, press a button, powerful solutions. And then we have our production series unit, the Nitor, which does involve our automated software, which starts introducing agitation similar to our support removal units that use different ways of agitating mechanically to be able to vary frequency. This can work with much higher volumes, much larger working envelope. Both of these solutions are considered suspended rotational force technology. So essentially, you're putting parts within media, and the big difference here for us is being able to digitally control that amplitude and really be able to control the force applied to that part. So that's the real power of suspended rotational force, which is really unique in the industry, being able to dial in those frequencies to be able to vary controls to handle your most fragile part all the way up to robust alloys. So that's the unique power of suspended rotational force. So if we look at a cross section of the SRF technology, essentially what you're looking at is us being able to control what we see here is the amplitude is Y1 and the potential energy is Z1. So we can really control this amplitude to really optimize that dwell time, optimize the time that this part is submerged in media. And what also happens when we're able to control the frequency, we start to generate this additional force that creates this additional rotation for us. So while this part's submerged in media, it almost rotates almost like a planet, orbiting. It rotates itself, but it's also rotating on a larger axis. That's what we want to be able to do to really optimize that time that the part is submerged in media. And being able to digitally control that is what gives us the unique advantage. And then we also have the hybrid solution. In the hybrid solution here, we have one machine that falls in this category and is very powerful, and it's the Deci Duo. So really, this is a spray technology that also involves suspended solids. So it's very versatile, being able to adapt to different support removal technologies or support removal challenges, as well as surface finishing challenges, all in one machine. So it's unique in the sense that it uses a spray technology, but instead of high volume like we're talking about with the VVD technology, this is much more direct, higher force with suspended solids. So it's much more of a mechanical means of removal. So excellent for different surface finishing. We've had a lot of success with this technology with powder removal. So MJF and SLS being able to remove powder and do initial surface finishing all in one step. And really the unique advantage here, or the key word that I like to point out here is the fusillade technology, really the controlled jetting and being able to either provide a high powered blast to be able to be more aggressive for more robust parts, or being able to dial it way back to even surface finish different polyjet or FDM parts, SLA parts. So a lot of flexibility with this unit as well. So this is a quick schematic of what that looks like. We have two single axis jets, those high powered jets that we can control with our automated platform, and a turntable in the middle as well that allows really complete coverage as we're able to move those jets up and down, back and forth, and rotate the part. So a lot of advantages to be able to dial in if you want to just focus on a specific surface with this, or if you want full coverage, just a lot of flexibility. And really what gives us that flexibility across all of our machines is the software. So just a brief software overview, because I know we're running up against the clock here. We have so much to share, but really what it boils down to is the agitation algorithm. So we don't take just a single approach. Other machines, you might just find you sort of turn it on and set a temperature. We have pre-programmed recipes that vary the agitation levels and temperatures. One of the examples I like to use to have people sort of wrap their mind around it, if you were washing your dishes at home, you wouldn't just spray your dishes and just leave it in one spot, right? You would, if you had a bowl in your hand, you'd be rotating the bowl, you'd be rotating your hand with the sprayer, you'd be maybe varying the temperature, hot and cold. That's what we do, and we automate it. So we're able to dial in for those needs. For those fragile parts, we can dial back the temperature, take a less approach as far as using agitation goes, or we can take a more aggressive approach for those robust parts to really optimize and dial in that cycle time for customers. And the beauty of it is once you dial it in, you can save it. So a user doesn't even have to worry about all those background parameters. They can just pop a part in, call up a recipe or an agitation algorithm and press play and get those repeatable results that we talked about at the top. So that's the power of automated. So it really becomes very intelligent for the operator and really gives them peace of mind. You know you're running these optimized, proven out algorithms, and you're also able to have these other advantages such as maintenance reminders, different alarms to make sure that this process is remaining in control. So that temperature that you set, automated will be able to understand if you're getting out of range. It'll be able to understand, if your tank level is getting low and that's throwing off the pH balance. So all these reminders, they give you peace of mind. So you don't have to worry about these things. Automated is going to run the cycle for you and also make sure that anything that impacts that cycle is going to be monitored as well. So very, very powerful. So one of the things we like to touch on, even moving forward, automated can go beyond just what it's doing today. You have this traditional workflow where it goes from the user, printer to finisher. We like to talk about this digital thread, and we're doing a great job connecting that today. And in the future, what we're looking to do is getting to a position where users can just upload their STL files, and we can just tell them, hey, this is what you're looking at for a post-print cycle time, a post-print solution, a post-print technology. So we've started to unveil what we call our connected technology. So I just wanted to share this to give you even a view down the road of the direction this is heading. And if as our customers adapt the software technology, they're really setting themselves up for a great foundation for the future as people introduce digital factories and so forth. So we do have a proprietary DDT file. I won't spend too much time on that, but it's really taking in all these different factors to make sure you're getting an optimized solution. And the last point I'll touch on is our chemistry. We have proprietary detergents for all of your common support removal needs, whether it's polyjet, FDM, SLA, and we also have different medias to address both the SRF technology where you're putting apart, submersing apart, or it's the TAF technology, the thermal atomized fusillade of the DESI Duo with suspended solids. So you're able to take a more aggressive approach with more of a spray technology for surface finishing. So one of the beauties that I always like to touch on for our detergents is they are pre-mixed. So you don't have to have a chemist in house. You don't have to worry about dosing as your solution evaporates. They're all pre-mixed. On our spray technologies, they're actually auto-dosed. So you don't even have to pick up a bucket. It's all done for you through the automated platform. So again, a lot of peace of mind from a lot of different angles here. And we'll wrap it up by just kind of saying, we understand sort of the tongue-in-cheek message here from Mr. Deming, saying it's not necessary to change, survival is not mandatory. We know that in order for additive manufacturing to truly be leveraged, this opportunity needs to be presented to really the masses that are trying to leverage additive manufacturing. And we're taking a lot of pride in doing that with our 0 to 1 innovation. So thank you for your time. I hope I wasn't too fast for you. I know there was a lot to cover there.
Okay, well, since we haven't had any questions, if you have anything for the webinar you'd like to reach out to, please reach out to us at Submetrics, a division of Javelin. We'd be happy to help you out. We will be having our post-process machines are going to be arriving in about a week in Oshawa office. So, you know, if you want to come and see some of them in person, you'll be able to do that, or we're more than happy to help set up a tour to get on to post-process in Buffalo. So hope you enjoyed today's webinar. Thank you very much, Andy, for sharing with us. And again, if you have any questions, feel free to reach out to us at Javelin. Thanks.
Thank you, Mark.